Hey there guys, and welcome back. So, I've been working on a rather large project, and part of that project had a need for nodes that allowed you to dynamically increase the number of inputs. And at first I did a video, and in that video I basically just ran over a minimal amount of code that you needed to get this started, and basically said, hey, you know how to do it, I'm not going to bother posting any code, and you can figure everything else out on your own. But as I was watching back the video and considering what would be necessary in order to have an actual complete node set up and the different options that you would need in order to keep track of things, I realized it was not nearly as simple as making out to be, so we're doing this video in response. So, as you can see, I've set up a test sample here, which has a variable number of inputs and a variable number out. Every time that I add an input or remove an input, it changes the number of inputs available. So for example, right here, I'm going to remove index 0, and you can see that we only have 0 and 1 now, and the bottom one shifted up. That one is obviously the extra one. If I reconnect this, there we go. And these outputs are resampling. This is one of those things, this is just for the demo, but the idea here is that as the node changes, you can also update the code in the background to compensate. So let's go ahead and look at the code, what it was required to actually get this working. And then after we're done looking at the code that I wrote as a demo, you can go ahead and hop over to the GitHub where I have the base class that you can just subclass off of and get to work with your own nodes. All right, so this is the base class that I came up with. I'm calling it variadic node because variadic functions are functions with a variable number of arguments, and this is basically the same thing. I am extending from LGraph node here, not strictly necessary. And if you want to watch the previous video I did on LiteGraph, then you'll understand why. LiteGraph, the documentation technically says to use functions and work off that, but in their own code, in places they use classes, and I think classes are just a better syntax. That's the TLDR. So, hopping into this, basically, what we are mostly concerned with is on connections change. This is the callback where we're going to add and remove connections as necessary, add and remove new slots as necessary, new inputs and outputs. So this will be the main chunk of it, but let's go over a couple little things really quick. First off, in the constructor, we are going to have this.vars. That's going to contain all of your dynamically added inputs and outputs. So as you can see here in add var input and add var output, it's basically the same code. We just modify it for add input and add output. Instead of using just one function, I wanted to keep it as close to the original code as possible. So that's why I broke it up into two separate functions. Otherwise, it works more or less the same way. It just registers a new dynamically generated input whenever you add var input, and you use this in place of add input. So if you wanted to add a normal input that is not dynamically generated and does not keep on adding itself and replicating itself, then you use that. Otherwise, you use this one. Same thing with output. In here, name, type, and count. The most important one is count for the record, and we'll go over why that is. However, having the type available makes my life a lot easier, and name is just there for posterity's sake. We don't actually use it in the code, but it is there just in case. And to go over the last bit of code in add var input, after we add the input and we're generating a name right here, I'll go over that in just a moment because that's more important for on connections change. We go ahead and increase the count, and every single time you add a new input, you need to increase the count. So moving on down to on connections change. As you can see, we have a few different arguments that come into this function. The type is going to be input or output, as you can see right here. So this is input, and then the else statement would be LiteGraph.output. Technically speaking, input and output stand for 0 and 1. However, I can never remember whether 0 is input or output. I would think that 0 is output, but I always second guess myself. So we are just using the input constant on LiteGraph. One of those things, better code anyway. Next up, this slot. This is actually the slot number, and this is useful for removing the inputs or the outputs. After that, we have connected. Connected is true if we have just connected to this input or output. Otherwise, it is false. Link info gives us info about what that link is between the input and output, whichever one was added or removed. Now, I did open up a GitHub issue here because I was looking at the source code and I noticed that on connections chain is always going to pass true, even if link info is false. This specific section of code comes out of the configure portion of the code, and this would be from cloning or from loading from file, from loading from JSON. So I thought it was weird and incorrect for the link info to be null if we're not actually connecting, because that means we're connecting to nothing, right? Which is not a connection then. However, Atlas on here does point out that this is a way to double check that the newly configured node was configured properly. Again, assuming it was loaded from file, a cloned object is not going to have, as I point out here, any link info to begin with, because cloned objects do not clone with their connections. However, he does have a point that if you are loading from file, then that link info is going to be null, and that is something that you will need to check in the code just in case. So keep that in mind, and that's why I'm bringing it up. However, I am not checking for that here only because we're assuming that that's not an error we're going to run into. Now, there is a corner case to that I will get to in a minute. Back to cloning. We'll talk about that in just a minute, but in general, it really shouldn't be an error, so that's why I'm not checking for it in on connections change. Next up, the link info. We're not, again, necessarily concerned about that right now. It doesn't help us with this logic that's inside this block, but it would help us if we needed to double check that like we were talking about on the issue. And then the input info will give us information about the input or the output itself. So now we're going to talk about how exactly all this magic works. And in order to explain this part right here, we will now return back up to generate name, which I glossed over earlier. The default generate name function, and you can replace this if you'd like, is var name plus this.join plus number. So if we hop back to my example, as you can see, we've got index dash number, sample dash number. If you want to change that, you can, and the easiest way to change that is by changing the join. You can go ahead and change that as an attribute on your subclass. Otherwise, you can override the generate name function, and everything should work perfectly well. Again, so long as you have a character as join. If you change join to be an empty string, that is going to break it. But so long as you have an actual join string and it's not empty, then everything else should work correctly. So back down to on connections change, and now we understand why we are trying to split this name by join, because if this is one of our dynamically created, one of our variadic inputs or outputs, then it should be split by join. This allows us to go ahead and have other inputs and outputs, like in our example where we have the length as a non-variadic input. So that gives us a method for differentiating between the two. Obviously, if it does not pass, then we skip that. Otherwise, we can get the name and we'll be able to look up the input or output using this variable name. Also, we can make sure that it's registered just to be sure, just in case this happens to fit. So if this just so happens to be a valid name, in the form of some text, join, some number, but it's not actually one of the ones that we registered, this check right here will catch it. And we can obviously get the index number for that input. The easiest thing in the world is when we get a connection, when we need to create a new input or output, that very simply, we just generate a new name with it with the count that we have stored in that object and the type that we have stored in that object. And then we just need to update the count so that the next time we do it, we get the correct number. So removing it is a little bit more interesting. As you can see, we need to make sure that if we only have one left, we don't remove it, because if we remove it, we can never add more. So we have that check right there. Then for inputs and outputs, we basically do the same exact thing. Again, I'm keeping this code separate just for clarity's sake, but these could more or less be the same code, and then I could just base this function off of, this function and this function off of whether it's an input or output. But since it's only two places, rule of thumb is if it's only two places, don't bother simplifying it, just keep it separate. So what we do is we first remove the slot. So that's going to remove it. That's what we're expecting to do. Next, we need to iterate over all the slots and rename everything after that name. So, for example, if we have 0, 1, and 2, as in the sample that I did at the beginning of this video, and I removed the 1 index, the 2 index became index 1. So, what that's going to look like is we remove index 1, and then we need to start from that index and go up until the rest of the nodes that we have, the rest of the inputs that we have rather, or outputs if you're down here. And we need to rename each of them. So next name is going to be generate name var I plus 1 because that's the next input that we need to get to rename. We get that input by the name right here, find input slot. And then once we have that input name, that input slot, let's say, we can then change its name to be the correct name, which is I. So on the first iteration, I would be 1, okay? And then we generate the name for 2. So now we have, for example, index 2, right? That's our example. So index dash 2 is the next name. Index next 2's input object we then get through this function. And then that guy's name then becomes generate name, which would be index plus 1 because, again, I is index on the first iteration here, and that becomes index dash 1. And if we had like 7 or 8 of them, obviously that would iterate through all the rest of them. It would iterate through index I equals 1 through I equals 6. I believe I just said 7 of them, so 6. And then it would, again, grab the next one in line with this line and rename it to the previous number. Again, remove output does the same exact thing. And finally, for both of these sections, we decrease the count by 1. All right, and now that we're done with on connections change, we can double back to clone. So clone is necessary because when we clone the node, it's going to copy all the inputs and outputs directly. But the point of this dynamically growing and shrinking node is that it always has the minimum number of inputs or outputs possible. And when you clone a node, as I stated before, and I said that we double back to this when I was talking about the issue on GitHub, it actually comes with empty links. It doesn't have anything on its connections. So for that reason, we need to actually get rid of any of those empty connections, inputs or outputs. So that happens pretty easily, to be honest. First off, we call superclone so that we can get our new object. And then before we return that object back to the parent function, we go ahead and just go through our whole entire list of vars in here. We check the count. If the count is 1, that means we have no extra nodes, no extra inputs or outputs rather, to get rid of. Otherwise, we go ahead and generate a whole bunch of names to get rid of, to look into our inputs or outputs list and see if they're in there and remove them if they are. And then after we do that, we go ahead and just reset the count to 1, and we are good to proceed. So this is very simple. We just go looking in inputs and outputs for the input or output we're trying to remove, the var value, the var name that we're trying to remove. And if it's there, we just splice it out. Easy peasy. I will say this is one of those situations where if we wanted to, we could include IO in here, for example, and set this to output right here, or even, for example, LiteGraph.output if we wanted to. And that would make this code a little bit cleaner, but again, it's a minimal gain for a bit of extra housekeeping, so I did not think that was necessary. Otherwise, at the very end of this, after we've done making changes, if we removed anything at all, that's what this remove.length is, we actually need to have the node update its visual size, because it will only do that when the inputs or outputs changes, or when some other size changing event occurs. And that's unlikely to happen anytime soon, in which case, let's say we had 20 dynamically implemented inputs, well, then our node is going to be just super tall for no reason because it's all empty space. So we need to recalculate, recompute size, and pass that back into set size. And then we can go ahead and return the node. And that is the entirety of the base class. So scrolling down here, this is the demo class I made. I made it as an array because I figured that was thematic with the last video I did. And then the sampling part is so that I could have variable outputs. So in this situation, each of the outputs gets to grab a random sample of the inputs, and that is set by the number of sample is set by this input right here. So as you can see, if you want to add an input, it's the same as always. If you want to add a variadic input, then you just use variadic input instead. If I wanted to make this number, I could. It doesn't necessarily matter. As you can see down here, I called this array because it's outputting arrays. So nothing changes when using these functions themselves in terms of arguments. They're meant to function exactly as their original replacements. In this demo, I have a couple other things just to make the demo run smoothly. So for example, this update flag just tracks whether or not we need to update the output, because otherwise, every single time the graph ticks, because the graph is constantly ticking if you have it on run mode, it's going to automatically update the outputs. It's going to run on execute down here and resample the inputs. So I don't want that happening, so I set an update flag if necessary. And then I also need to keep track of what our inputs are. So the last output is actually the full list of var inputs, and the last sample size is obviously sample size. So this allows me to track whether or not either of those change. Otherwise, as we roll through here, I set the update flag on connections change, because if a connection is changing at all, that means that either an input or an output changed, so I should resample. And then all the other magic is just in here on execute. And in this case, I'm running through all the inputs. I'm iterating through all the inputs, checking only for the ones that start with index. And it's one of those things, you could do a more complicated, or a more specific, I should say, search for input nodes if you want to. In this specific example, it was just easiest to just say, okay, just look through all the inputs and only find the ones with index. So for example, if I had this dot add input index max would be, I guess, the way to say it. Now, this is not actually how I would say it in practice, but just for the sake of the argument, obviously this one would invalidly pass this test right down here, right, and get added onto my output results, which I would not want, so I'd have to rewrite that one. But again, this code is specific to this demo. However you're going to be handling your variadic inputs, you just write the code as necessary. Next up, I am just checking for changes in the input, making sure that the input is the same length or a different length, and then checking each input piecemeal in case it is the same length, because even if it's the same length, the value of the inputs could change, and setting the update flag as necessary. And then obviously if sample size changes, we'll be setting the update flag. And if the update flag is not set, then we return, because again, I do not want the output changing each and every single time that the graph ticks. And finally, obviously, we're grabbing random samples, so for each of the outputs, just going over my output lengths, check if it starts with sample, again, just like this. And again, if you wanted to be more specific with how you select the outputs, you could update the code right here. And then this is just obviously code to randomly select outputs from the input set. And we set output data using I, which is the input index. This is the slot. You could do other things. There are other functions in LiteGraph that can help you find the correct input or output slot you want. So go ahead and look through the source code, and check out what functions are here and figure out if there's something else that you would prefer to use. And yep, that is it. So that is the entirety of it. Honestly, it took me a little bit longer than I thought it was going to be to update the code to be more comprehensive. But we are here, and as I said, I will get this up on GitHub so you can actually get the base class yourself, since it is more complicated than previously thought, and that will save you a little bit of work of getting it set up. But it is possible in LiteGraph if you are curious to have these inputs and outputs change. And now it is much more easier than if you had to do it manually. Now, that being said, if you did not want to download my code and you want to do it from scratch, again, there are certain assumptions you can make with your own code that would make the code more streamlined because you wouldn't be dealing with edge cases. But again, one of those things where in that case, your code will only work for that one case, or maybe another case if you get lucky. It's not going to be generally applicable. And with that being said, as always, guys, thank you for watching, and I hope you have a great, wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.